I'm Siona Bose. Welcome to my channel, Learning Fails Live. Today we are going to talk about ionic bonds. Firstly, we have to understand where the concept of ions come from. Let's see. Let's say in any kind of reaction, there's a very electronegative atom. An electronegative, like we explained previously, that electronegativity it is the attraction of electrons, basically. Attraction of electrons. In case of covalent bonds, we saw it was attraction of the sharing electrons, and then we could decide whether they were non-polar covalent bonds or polar covalent bonds. But here, it's just like the attraction of the electrons. So sometimes it can go to this extent that it can, like one atom can take away an electron from another atom. The more electronegative atom can take it away from the other one, leading to two oppositely charged atoms. Two oppositely charged atoms. Those charged atoms are called ions. There are two types of ions. The positively charged ion is called the cation. Charged ion. And the negatively The positively charged ion is called cation. And the negatively charged ion is called anion. We can remember like the cation has the T, which is shaped like a plus sign, so we can remember from there. And in case of anion, a negative ion, here N, a negative ion. We can remember like that, which one is positively charged and which one is negatively charged. Now that we know about ions, we can move on to understanding ionic bonds. Let's take an example of NaCl, that is common salt. NaCl. Let's see the structures of their atoms. Firstly, sodium, which is actually like this, 11Na, because it has 11 protons. Let's see. Na means it's actually the nucleus, but I'm writing Na as the nucleus because to represent that it's sodium. This is the first shell, second shell, and third shell. Let's make the electrons. The first shell always has 2 electrons. And now the second shell, it has 8 electrons, full capacity. And lastly, 1 electron. Still we have to check whether it sums up to 11 electrons. 1, 2, then here 2, and here 8. 1, 2, 3, 4, 5, 6, 7, 8. So 10 plus 1, 11. But over here, this is actually like, let's draw this chlorine. 17Cl, we draw like this. Here I'm writing Cl as the nucleus to represent that it's chlorine. This is the first shell. second shell, and third shell. 1 minute. Make space for the electrons as well. Sorry. Okay, firstly we have 2 electrons here. Then, as usual, we have 8 electrons in the second shell. 8. 1 minute. And now we move on to the third shell, which has 1, 3, 5, 6. To complete the, let's check though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it's okay. Now over here, it has 17 electrons, and here just 1 electron in the outer shell. None of their valencies are being, the valence shell capacity is being fulfilled. Now, since chlorine is much more electronegative than sodium, it pulls this electron towards itself. So this now becomes, it's gone now. And now this shell remains empty. And here, we don't need this shell because it's empty, and now we just remove it. I've shown the transmission of so I'm just erasing this arrow. And now the electron which was there, the only one sole electron which was there in the third shell of the sodium, has now gone to this chlorine. What is happening here? Here now the valence electron becomes a second shell, so its valency means its capacity is fulfilled. And here also the outer shell, which is the third shell, its capacity of 8 electrons is also fulfilled. So, and now since this has led to 2 oppositely charged, and how? Here now it has 1 positive charge, since it had 1 electron here, but now it has 10 electrons, but 11 protons, which led to a +1 charge. It is the cation. And here it had 17 electrons, but now it has an extra electron. So there are 17 protons, but 18 electrons. So there is a -1 charge. It is the anion. Now, we know that opposite charges attract, which leads to the ionic bonds. We need to remember that it's not only just this shifting of electrons, then we have to understand that how the charge is happening, and then we can make the ionic bond. That's how it's happening. Mainly, the charge is the reason why this ionic bond occurs, not the electron transmission, but the charge matters. Now, you may take a look at the board. Maybe I'll talk more about ions. Let's continue. We were talking about NaCl. NaCl itself is not the molecule. If you have noticed, then salt exists in form of crystals. NaCl forms a three-dimensional shape and forms these crystals, NaCl crystals. And Na and Cl exist in a 1-to-1 ratio in these crystals. in the crystals. Now for ionic compounds, for ionic bonds and all, it's not necessarily that there has to be a 1-to-1 ratio. There can also be different proportions. Like, for example, we have MgCl2, an ionic compound. MgCl2, in case of this, Mg has to lose 2 of its valence electrons, which are in the third shell, to the two chlorine atoms, and that means there has to be like Mg2 plus and 2 Cl minus anions, and here should be cations. There was Mg2 plus cation, 1 cation, and 2 Cl minus anions to form MgCl2. Here the ratio is 1:2 anyways. And that is what we can understand from here, that here in case of NaCl it existed in crystals, and here it can be in different ratios as well. Another example is NH4Cl, that is NH4Cl, which is ammonium chloride. Ammonium chloride. Over here, the whole NH4, that means the whole NH4 molecule, the ammonium ion, NH4 plus. Because the whole configuration of nitrogen covalently bonded to 4 hydrogen atoms has lost 1 electron, due to which it is the ammonium ion. This is the ammonium ion. And then we have Cl minus, which is the chloride anion, ammonium cation. And Cl minus is the chloride anion. Now you may take a look at the board. Hope you enjoyed this episode, and please like, share, and subscribe to my channel, and stay tuned for more videos. Thank you.